Hello everyone, my name is Jacopo Abramo. I'm a PhD student at the Leibniz Institute for Photonic Technology in Vienna, and today I will present napari-live-recording, which is a Napari plugin which I use for camera recordings. As you know, Napari is a fast, interactive, and multidimensional image viewer built on top of Qt for the graphical user interface, vSpy for GPU rendering, and the scientific Python stack as NumPy, SciPy, and scikit-image. It is a highly customizable software thanks to a flexible plugin engine capable of extending its functionalities depending on the user needs. And even if it is only an image viewer, it could also be extended as a camera recorder software, which is what I attempted to do with this plugin. So napari-live-recording is a plugin born as a side project to control a camera through Napari to make prototyping of our cameras. It has a GUI interface which you can use to control a camera device directly from Napari and acquire images which are directly shown on the viewer. There are different acquisition modes, such as a single image snap, an album collection, live acquisition, and video recording. There is also a common interface for all devices to provide an easy integration of new cameras with minimal effort and high customization. Here we can see the GUI structure of the plugin. At the top we have the device selection GUI, which allows to select which type of camera we want to add to our controller. Then we have the recording options, which we can use for snapping, creating an album, live, and recording. And also the parameter settings, which is the customizable area which the user can use to create his own widgets in order to add the control of different settings of the specific camera. Finally, we have a ROI setting widget, which allows to expand or reduce the region of interest of the acquired images. There can be multiple devices active at the same time on the plugin, and they can be controlled at the same time, and also each device can be deleted dynamically while Napari is still running. As a reference example, I will show a couple of live recordings from this Ximia CIB64 camera with 1.1 megapixel resolution and around 3000 frames per second as top speed. Here we can see a live acquisition example. We can check the exposure time and changing as we want it, and then we can start the live recording. And during the live recording, we have some widgets which can tell us how many frames have been transferred from the camera, how many frames have been skipped due to transport from the physical layer, and also how many frames have been skipped due to the APIs being slow. Here we can have a video recording example, which we can select how many frames we want to collect, and this will be the number of frames which are then shown on the Napari viewer, and they can be slide through as a sort of a stack of images collected. Finally, we have an example of an album capture in which we can collect multiple images on the same layer and slide through them in order to see all the frames singularly. To add new devices, it is possible to share a common API interface, which by using polymorphism and the signal slot mechanism of the Qt framework requires minimal effort to integrate. Whenever a new device is added, the plugin automatically identifies its presence and directly shows the device on the selection GUI. For each device, as you can see, you can set different parameters that can be described in order to control single settings of each camera. This ranges from exposure time control, frame rate calculation, color conversion, bit depth selection, and so forth. There is a series of widgets integrated into the plugin, which are available to the user to create their own specific plugin GUI settings, and it requires minimal effort to integrate. And each new added parameter is then shown on the main GUI relative to the specific camera that is being added. A more detailed guide on how to implement new devices will be redacted in the plugin documentation. But as a reference, you can also check the OpenCV class implementation for a quick example on how to integrate new devices. This is a listing of the APIs needed to integrate a new device. And as we can see, we have 4 main methods. One for setting up the widgets of the specific camera at startup. One to connect the signals of the widgets of the shown widgets of the camera to the device slots, which can be defined by the user for its own purposes. Then a frame grabber method in order to get the latest frame acquired by the device, and then a region of interest change method in order to change the current shape of the image that we want to capture. The plugin is still in alpha stage of development, and there are further developments which are still undergoing. New features will include the support for new devices, and for this all contributions are welcome for any new devices that want to be added into the plugin, and also adding the possibility of implementing a customizable processing pipeline on the single acquired images, or eventually the live recording, or the album, or the video recordings. It could also be possible, but it has not been tested yet, to use already existing Napari plugins, which are used for image processing purposes directly on the Napari plugin environment. You can check the GitHub repository or Napari Hub for more detailed view of the plugin. And in case you have any questions or need support on integrating the new device, you can contact me directly. And that's it for me. So I thank you for your attention, and I hope you enjoyed this small talk.